For those of you who have joined, I'm Maya Palmer. I'm the editor of Global Corporate Venturing. But I think everybody has mostly joined, so let us begin. I am going to introduce the panel in just a moment, but I wanted to just take a moment to give us an overview. So this is our panel. I am so pleased to have put this lineup together. We couldn't have a better set of people to take you to what is happening right now. So in no particular order, but Christoph Jurzak, founder and partner of Quantonation, who is probably, I mean, Christoph, are you still, I think he's still the only really quantum focused fund, or at least was one of the first, has a brilliant overview of everything that's happening in the market. Certainly one of Europe's most prolific investors in this field. Marcus Oliveira, who is the managing director of Global Venture Capital at BASF, and a very early investor on the corporate side into quantum computing. So a brilliant perspective and kind of what, all the stages that we've gone to and how realistic it is now to really start using this for corporate purposes. Then we have Tobias Grab, who's the co-founder and chief strategy officer of Kipu Quantum, a quantum software company. So, and also one that I think we have to disclose that Christoph and Marcus have both invested in Kipu. So there is a relationship there, but Tobias is really going to give us the software angle on this. And then last but by no means least, Stefan Elrington from IBM, global lead for startups there. And I'm really excited to have someone from the hardware side on this panel to really talk about where we are on that roadmap. And I think Stefan is probably going to share some interesting news with us shortly. Before we get to that point, I just have a few slides. I promise this will take less than 5 minutes to run through these, but I just wanted to give an overview of sort of where we are with quantum now. We obviously saw a huge wave of investment over the last couple of years, starting from roughly 2016. This is the number of quantum companies being formed, and then it's followed with a sort of 3-year lag, roughly speaking, by VC deals. So we see those really peak in 2022. And this year has obviously been a little bit more subdued, although we did see some really big deals like the, 100 million euro raise of Pascal. So it's by no means quiet. And but obviously we are now kind of, the big question is, where do we go from here? Does this wave sort of begin, do we start, are we on the cusp of a new wave where we'll see this grow even further? Just a couple of stats here about sort of corporate versus general VC backing for quantum computing deals, which may interest some of you. And this is based on sort of some of GCV's own data as well, which is really showing that, corporates ever since sort of about 2020 have made up a really large part of those investors that are investing in quantum. So I think, and that has remained relatively steady, even though the numbers dropped a little bit this year. The percentage of corporates that are going into those deals is still relatively high. So it feels to me like this is telling a story about corporates being quite interested in being, straight out of the gates when this starts to have proper business advantage for them. A couple of, this is from the State of Quantum Computing report, just a couple of stats that are showing a sort of generally high level of interest, trying to develop real life cases for quantum computing, and business leaders being willing to put some money towards experimenting with this. $1 million is probably not a huge amount in this context, but it shows that there is some interest in putting real money behind this. This is really setting us up for the discussion that I wanted to have today, which is that we're seeing more and more promises for quantum advantage, which are really in the very near future. So this year or next year. But at the same time, there was a recent story about UBS sort of stepping away from use of quantum computing for trading, feeling that it wasn't going to give it significant advantage. So I wonder whether we're at a point in which some of those early adopters are starting to lose faith, and it would be good to discuss kind of whether is this premature? Are we just on the cusp of that quantum advantage, and they should hold on for just a little longer? And this is really, I think, I don't want to steal your thunder, Stefan. So I just added this slide because, this is the sort of IBM quantum roadmap. I'm not sure whether it's been updated a bit further from here, but really there are some promises of kind of significant numbers of qubits coming, a modular computing style that allows us to get to some really high numbers. So I think this to me shows that, there are things coming. Again, we're not talking about the distant future here. really this year, next year, and 2025 are showing some significant improvements. So I think that's a good place for us to kind of begin. Hopefully I've kind of teed up the current state relatively accurately. This panel will tell me if I haven't, but what might be good is to begin really with talking about the latest IBM news. And just before we go to that, I have one more housekeeping thing to say, which is, we are encouraging people to ask questions. So if you have a question for the panel, use the Q&A button, put your question in there. I'll keep an eye on those. And if we start to get some questions, we will really try to work those in so that all those who are participating live with this session will be able to kind of try to get their question answered. But now that said, I want to turn over to the panel. And Stefan, tell us, because this right before we started the session, there was kind of a super exciting press release out from IBM, which takes us further on this roadmap.
Oh, yes, Maya. So first of all, thanks for the thanks for the invitation. And it's really good to be here. And thanks to you and the rest of the GCV team. In terms of what you're saying, so what I heard you say is the next wave. And I really want to continue along that motif as we go through this panel today. Now, it's fortuitous in that in a few hours ago, IBM actually announced that we were able to take one of our large scale chips. So this is the 127 chip that we have out. And we're able to show results where we simulated a non-trivial model and we're able to show that we got results that could not be replicated at all on any classical brute force method. We had actually collaborated with some folks at the University of California in Berkeley, and we showed where approximation methods failed, the quantum method was actually able to show accurate results. And then we reached a regime in which the brute force methods could not actually get an answer, or the quantum result was able to get us an answer for that circuit. So it by far is really great news and evidence towards reaching a new era of computing, where we're going beyond what can be simulated, beyond what's achievable by these classical devices, which really tees us up for that endpoint of quantum advantage.
So this is a sort of stepping stone towards quantum advantage. I mean, it's quantum advantage of sorts, right? But is it still the case that it's for quite specific use cases, and what we need to do is to have that more repeatable for everything?
Yeah, I would say that, 100%, we need to really realize that for quantum advantage, we have to show it universally, number one. And then also it has to be something quite useful as well. Now, for those two criteria to be met, there is still lots of active work going on. At IBM, we believe that quantum advantage can happen before fault-tolerant quantum computers. So using some of these nearly intermediate scale devices, we can still reach there. And but at the time being, rest assured, quantum advantage is still something that hasn't been reached, but we're getting there.
Yeah. I'd love to turn to the rest of the panels to see what your reactions are. I mean, does this, how excited are you by the fact that we are meeting these milestones? Maybe if I start with you, Marcus. I mean, does that were you expecting this? Did it surprise you? Are you?
Well, we already had another example of quantum supremacy a few months ago, or I think it's now 12 or 15 months, that Google communicated based on an experiment that they did with the 52 qubit hardware. They also found a problem, at least, where quantum computing was more, let's say, efficient than the classical computer. So, but to be honest, I mean, we are not seeing Moore's law here. I personally, I'm a bit disappointed about the speed of development on the hardware side, and so that's something where there were projections in the past that we would see soon from the hundreds, would go to the thousands, and then to the tens of thousands of physical qubits, which is not happening. And of course, the challenges are known, but I think going back to 2018, when we at BASF Venture Capital had done our first investment in a software company in the quantum space, expectations at that time certainly were that in terms of hardware, we would be further down the road today.
Right. Okay. So is this affecting your kind of willingness at this point to kind of, invest? I mean, I think we can get into this sort of investment climate question a little bit further, but I'm just wondering for, a quick reaction. Are we in a holding pattern? What do we need to see before, for confidence?
I think the good news on the opposite, on the software side, I think we are making great progress at the same time, more than expected. That's how I would summarize it. So there are many companies today who are successfully simulating quantum computing, let's say techniques and logics, and of course we have new big topics like generative AI that we are discussing today. And guess what? That's something in terms of the logic that is applied, where let's say the quantum computing logic also can help a lot. So I think use cases are popping up, becoming more and more. Software is making huge progress. So yes, but it's unfortunately, and that, let's say, that compensates a little bit the disappointment about the long wait for the hardware, at least on my side. That's how I would put it.
Well, we'll come to the software in a moment with Tobias, but Christoph, jump in here. Do you agree? You have both software and hardware investments. So where do you stand?
Yeah, first, I would say we were all expecting this announcement from IBM, so they had hinted that something would come. So very happy it comes today. Pretty excited, and I put in the chat the paper in the New York Times, I think, and I quite frankly, I think of course there will be debates about what it represents exactly, but I think it's a really important milestone, in particular with respect to benchmarking, with the best classical algorithms they have for this kind of problem, and that to me is very big news. That's something I would have expected, maybe something a little bit more practical in terms of use case, and we'll see that coming maybe for chemistry, for other applications. But I think it's a huge milestone for the whole community, and what I like is it confirms, or it's pretty much in line with what I've been advocating for since the beginning, since we started investing in this field, for pre-fault tolerant approaches, not error corrected, essentially doing with what you have, with what works, with the machines that are available these days. And I think that's, yeah, definitely one of the very first examples in that direction, with a really authentic, very good benchmarking. And I like that very much. I think I tend to agree. I think that's the start of something from my perspective. To the point about the hardware, I would say, I have a slightly different view on that, because I'm seeing software companies in my portfolio and hardware as well. I think, and to Marcus' point, I think this all started fairly recently. I mean, I started working and coding on an IBM processor by in 16. I think I was probably among some of the first to play with it, a couple of qubits. 16 is not that far away. I mean, we're talking now about thousands of qubits and machines coming online with thousands of qubits 7 years later. I mean, that's a huge move. I mean, with all the technical milestones that have been reached and all the progress there, I think I would say that's pretty spectacular in terms of progress on the hardware side. Where I would be a little bit maybe disappointed, or I think where things have not been as good as I was expecting, is more on their reliability, like the machines that we have, including IBM, IonQ, other platforms, etc. I think they're still not at a level where probably you could get into production, like with machines working with a high availability all the time, maybe 90–95% availability, something like that. They are still relatively fragile. It takes time to calibrate, etc. And it's true for all technologies. There, I think on the industrialization, on turning these prototypes, early prototypes, or first commercial products into something really that you can use in production, I think that is still a challenge. So that's something that the community, the startups, the companies need to overcome. But in terms of where we stand, I think number of qubits and the progress with superconducting and other platforms, atoms, ions, photons, etc. I think we tend to agree with IBM's assessment in the paper and the paper in the New York Times as well. We're really at the beginning of something. And this is a first milestone that marks the beginning of this transition to using these machines for real life use cases. So pretty optimistic, and I think that's important. It's going definitely into the right direction. Some caveats on, okay, will we have enough machines actually to go into production? I think that would be a big challenge from my perspective. But yeah, I think it's a big day for the whole community.
So it sounds like you don't need to really readjust your investment thesis on this too much. It's
No, not at all. I think, I think I agree with Marcus as well, and probably Tobias will speak about that. But our approach has always been, we have the machines that we have. Error correction is sometime in the future. I mean, it will take time to go there, and there's still progress to be done. So we need to focus on making the best use of these machines, the ones we have, with the software that are noise resilient, etc. And Kipu has been working on that for some time. They have very nice approaches to it. IBM in this paper gives the same, well, it works along the same way. So I think that's quite the contrary, actually. That's kind of a validation of the approach we have been advocating. Of course, we need also fault tolerant, and all companies are working in that direction. That will come, but for short term, for use case, commercial engagement with customers, we have the machines that we have. So let's make the best use of them.
Well, it sounds like you teed up Tobias quite well there. So it would be nice to hear a little bit about what Kipu is doing, and where do you think software in general can take us? How far down this road to real use cases?
Yeah, so basically, even if that is a very short description, we so my co-founder Enrico Solano found a universal compression method in order to shorter the circuit steps, so the time that the quantum computer needs to work stable in his special way to bring results to that algorithm. And our technology seems to work on all different hardware platforms currently. So we're working on the IBM machine proudly, and we are part of the startup program, as well as other machines. We just yesterday announced a collaboration with Pascal. So they are, if it's cold atoms or ion traps or superconducting circuits, doesn't matter for our technology. And we are now trying to find the use cases that could lead to early value due to quantum computing, together with the right hardware platform, in order to come from this era where we all waited for a long time. And I think that's also something that I wanted to put emphasis on, that we are maybe now in the turning point of this Gartner hype cycle, that quantum was oversold in order of timing. And these results that IBM and others are currently presenting shows that there's actually a pathway towards usefulness, and that by the announcement that you showed, Maya, for 23-24, that we will reach 1,000 qubits with a decent, reasonable quality, that will open the door towards first what we call quantum usefulness. So we don't care if it's supremacy or advantage. Does it bring value to the customer, and does it change the game? That is what we are trying to do in order to compress algorithms. Of course, that has also implication. We make them more specific. They're then specific to a hardware, specific to a problem. So we lose that general approach to full tolerant that is maybe decades away from reality, to the point where we want to jump with the existing hardware step by step together with the customer towards something that actually brings value to the system.
And you said you were starting to develop these kind of real use cases. Are you able to say anything about where do you think some of the first ones will emerge from? Or
I expected that question. It's rather difficult to answer clearly, because I can't see the future to fully make clear how the number of qubit, the quality, the potential circuit depths, and also the customer expectation of what is the early value will bring. What we're currently working on POCs with a governmental project as well as customers from the industry is, for example, battery materials, to understand that further in material science is quite interesting. Last year, we published a paper on an IBM machine. We were quite proud to get the best results in order for protein folding. So that's also, I think, an interesting case, that with AlphaFold and AI techniques, you can get to some great results. But if you have something that has not a strong data set, then you need to calculate. these protein folding approaches. And there you need a quantum computer basically, as well as optimization problems that are also on the roadmap for customers, a large group of problem sizes that we can address. And we get also approached by the financial industry in order to do risk assessment, portfolio optimization problems. So everything like that moves a little bit together. And for example, we had incidents where one of the well-known investment banks worldwide approached us because of our protein folding paper, saying that we can map our problem to whatever you can deliver that brings us towards quantum usefulness. So there are even like interceptions between these mathematical concepts that we put into boxes and call it use cases that can maybe also be merged and lead to, that leads me to the position that I don't want to tell you it will be an optimization problem on a Pascal device. I don't know yet. We are trying to match this multidimensional problem and opportunity space together.
Yeah, and I think it's fair to let you have a weigh in on this, Stefan, whether, again, on this use case question, if you have any thoughts on where do you think some of these are beginning to emerge? Or
Yeah, good question. It's really difficult to say because we are so far out to, providing that quantum advantage for a specific vertical. But when you think of the technology and, what types of problems are useful for quantum computers to fix. So I'm thinking here about simulating quantum systems. I'm thinking optimization. I'm thinking, even in the AI and ML space, quantum could be useful as well for training. One of the things that we find with looking at our startup partners is that a lot of them are working in quantum chemistry. That's a natural segue, given that, at the end of the day, whether it's looking at materials or, maybe some specific ligand to protein binding, you're always at this level thinking about a quantum system. So that's one area. Although I should say, have a big caveat that the problem sizes are really what's, a limiting factor to really get something useful. So but those are, 3 areas. And I see Christoph has his hand up. I'm not sure if that was an error, but or if that was intentional.
No, I wanted to react actually. If you mind, Maya, I cannot refrain from reacting to Stefan. But I think he's so just to add to that, and I think he's right. In particular, in chemistry, and something I want to add is that we should really not see these machines as here to do all the job, in particular in the chemistry workflow. And I'm sure Marcus can talk about that as well. I think for me, a quantum processor in this logic, like we have a company, Qubit Pharmaceuticals, that's developing drugs actually. So they're doing drug design. The quantum processor, they're running on GPUs and CPUs today, and some parts of the workflow will be dedicated to quantum. That's what they're trying to identify and to target. It will be minimal at first, will have an impact, positive, obviously, that we need to formulate, but it's definitely not going to be, let's solve Schrodinger's equation on 50,000 atoms and the quantum computer will do it. I mean, no, that's not it. And I think that's the reason why some corporates sometimes, I think, have expectations, but at the end of the day, the machine itself is definitely not going to be able to solve that problem as such as a quantum computer. To me, in many of these use cases, it will be a coprocessor. In a complex workflow, it will solve the need, maybe sampling, sometimes some other things, but that's what it will do. So we should be careful. And to Tobias' point about the hype, I totally agree there. We should be careful about what we're selling. For me, the quantum processor will be solving a small problem at first in a big workflow and progressively take more and more applications and have more and more impact, but it's not going to change everything from one day to the other.
Yeah. Now, chemistry gets mentioned a lot. So if only we had someone on this panel who knew about the chemicals industry, or actually we do, Marcus. But I mean, how does Christoph's point about it solving these small parts of the equation kind of is that how you were thinking about it? Or it sounded like you probably wanted a little more.
Yes, and I mean, it's that, of course, in terms of, and we are talking about business models, right? This is an investor forum, and the question is, where are the markets and where is the demand for computational power that is not available today? And so the chemical industry, of course, is a good guess. Just to give you an example, in 2018, BASF acquired a supercomputer called Curiosity that was booked out with internal requests from R&D within 6 months. So we got a new one just recently, a few weeks ago. We got our new supercomputer, and again, soon it will be booked out by internal requests from R&D to solve our multi-variable optimization problems that we have in chemical research and material research. So that has been mentioned, and that's simply true. So if you look for a customer who is interested in solving a big problem, big computational problems, then of course work with the chemical industry. I can only encourage you to work towards helping the chemical industry, because that's where demand is. But of course, we are not the only ones. We moved at BASF just from the R&D perspective, also looking at other topics where we see optimization requirements. One is logistics, of course. We have a very complex production site, for example, in Ludwigshafen, which is still the biggest chemical plant in the world. Extremely complex and connected manufacturing system. To optimize logistics around this plant is an interesting task as well. We have used and experimented with pricing algorithms around commodities that are, of course, feeding into the chemical industry, and trying to get a better hands on where could price developments go in the future. So we are developing more and more use cases in the classical material or battery material research that already has been mentioned and is part of the general R&D topic that I mentioned. So and if I look at trends in other industries, I see also big cases like but it's interesting. If you talk to the big German automotive companies, the big automotive OEMs, they are, for example, Volkswagen and BMW are very interested in quantum computing, but one is thinking about running their fleet of autonomous vehicles, and the other one is thinking about developing the next new battery material. So there's still some interesting perspectives and different perspectives of where their use case for quantum computing could be. And so yeah, but I think there's no discussion if material research, chemical R&D, pharmaceutical R&D will be a meaningful area for quantum computing, and that certainly will be the case.
And just looking generally, I mean, again, we have these, certain large companies, such as BASF, but also you mentioned Volkswagen, Airbus, I know have been doing quite a lot of testing, but there's just been a lot of piloting. And I just wondered if it was, do you see any signs of companies losing a bit of patience or a bit of faith with this, like the UBS example? I'm just wondering if, I don't know, it could be that we're at the beginning of the turning point in the hype cycle, but in the meantime, do we need to does there need to be a sort of message of reassurance or some kind of proof points to become more generally disseminated to?
I think, again, as I said in my opening statement, waiting for the hardware probably could create some pain to wait for the 10,000 physical qubit device and say maybe then we have it. There are, I think, probably many problems that need even more than 10,000 qubits to be properly addressed. So that's probably not the way, but I think from now it's a time where companies are moving from doing little tiny POCs to developing a real program, how they think and how they intend to apply quantum computing in their, let's say, innovation strategy and R&D activities, for example. And so you don't want to, as a startup, you don't want to be the one who is doing this 25,000 euro trial and they pay you for it and everyone is excited and there will be a board presentation. and after that, nothing is happening, right? So this should be avoided, but I think it also can be easily avoided by continuing to show what quantum computing can deliver by simulating that and starting to attack problems that can be attacked with the logic of quantum computing. Again, it's much of it is about linear algebra, and linear algebra, for example, is also the core of our large language models, speaking of generative AI. So why not building the bridge and saying, well, we simulate what a quantum computer, how it would operate. Let's start working on it today. And once the hardware is ready, we will switch over to the much better hardware.
Yeah, okay. Now I can see some questions coming in, and please do keep putting them into that Q&A function. It's quite a variety. Some people are obviously, you know, very well versed in quantum computing, others are beginners. So I'll let a couple of more questions come in before we turn to that. I wondered, in light of that kind of widespread, if we could turn for a moment to the perennial question, which is what type of quantum computing? And I know you guys all get asked this a lot, but I would love to get your view as of this moment in terms of how bullish are you on the various different types. So if we're talking ion traps, neutral atoms, superconducting, what is, I mean, Tobias, you've said it doesn't really matter. Your software will work on anything, so that's fine. But you may have a view actually on kind of which of these you think is kind of developing most promisingly. I don't know if you do, but
yeah, I have it, but it's a difficult question for me. I think I'll have to switch that over to Christoph. Yeah, so from my perspective, currently, I think we had some great results on ion traps, but not anybody yet gave a really good practical example on how to bring that devices to 2D, so to scale them up. That seems to be a problem. From my perspective, I don't see the future world that there will be one company who rules it all. I see that this will hardware will be a supply for software for combined devices like it is today. And I think there will be, I don't expect that IBM wins and Google and all the others said, okay, let's stop, IBM won, game is over. That will be a multi-technology and multi-company approach. And therefore, different hardware will potentially be have advantages and disadvantages for special kind of algorithms, for special types of use cases, and therefore I don't want to overstep my knowledge and visionary potential. But Christoph, what are you betting currently on? I know it partly, but how do you see the near future and maybe the far future?
Yeah, thank you very much. So yeah, maybe just one step back to explain what we're doing. So we're a fund dedicated to quantum technologies. That's as Maya explained at the beginning. So we've been investing since 2018 now in the field. We have 24. Well, we'll have one more deal, but we're closing at the moment. So 25 lines in the portfolio. Quantum computing, but not only, I'm not sure, well, this today is focused on computing, but there's also pretty nice things going on, quantum communications and sensing that we have been also developing for investments, obviously, on our side. I would say very clearly, we have made a rather large investment in neutral atoms with Pascal. So we were the earliest investor in the company at creation. Then we followed, succeeded in structuring a very nice round at the end of last year. I think timing was right, definitely. I think if we're talking a bit later about what's going on in terms of investment, and Maya showed a couple of slides a bit earlier, definitely closing in December was good and was a good idea to get to a large round. So we're very bullish on neutral atoms. On a slightly different way, I think there's a question about qubit numbers, coherence, single gates, etc. I am, and I've been, and I still am, a very big fan of hybrid approaches, analog and digital. So not only about the qubits and their fidelity and the coherence, but slightly different approaches. So it's different computing paradigm. We will not go into that, but I think for the short term, that's an approach that's very well suited for application and for Pascal in particular. One thing is true is that you need, and Stefan and IBM have proven the point that you need to get to a certain number of qubits. I mean, like still, I mean, people are always arguing about, okay, coherence, gate fidelity, etc. And that's a fair point. You need that as well, obviously, but you need to have a technology that scales, that gets you to the number of qubits that ultimately you'll need. And that's quite clear in the NISQ regime. We need to have technologies that can reach thousands of qubits, 1,000, 10,000. IBM has it in their roadmap. Neutral atoms can do it as well. So I think I would definitely think that in the short term, these technologies have an advantage. Other technologies in photonics, some kinds of superconducting processors with bosonic codes are more targeting fault-tolerant approaches, which is also obviously very good. And of course, we need that as well. So to Tobias' point, I think it's the combination for us as an investor, investing in different technologies, mitigating risks, obviously, that these different approaches have, also preparing for the future. Ideally, a platform like Neutral Atoms gets you some short-term benefit and then prepares also for the fault-tolerant regime and the longer term. That's what you can do also with superconducting processors. So devil is in the detail. You have really to look into the roadmaps of the companies. I think technologies will evolve. There will be competition. What's really important is the value we're bringing to customers in the short term. And for that, let's say within the next couple of years, you need thousands of qubits. I don't see a way around that. I mean, you have to have thousands of qubits and then, of course, get a good performance. But so, yeah, you really need to be in this regime.
Yeah. And I don't know, Stefan, if you want to jump in there. I mean, obviously, you know, IBM does have a roadmap to, you know, what looks like thousands of qubits relatively soon. So
so we do have a roadmap that really lays out how we're going to scale our systems to 10,000 qubits plus. However, I should actually add to this note that when we think about performance, so as Christophe was mentioning, yes, you know, scale is important. So how do we increase the number of qubits that we make available for a quantum system? The second thing is also the quality. So yes, those error rates, and I know there's a question again about single and 2 qubit gate fidelities, but then also speed, right? These are like the 3 metrics that we're looking into at IBM that drives performance. For each of them, we do have our solutions to, you know, both increasing speed, you know, increasing our quality, as well as increasing the scale of our systems. Some of them are out there in the world for you guys to see, such as, you know, how we're planning to approach, you know, modular type of QPUs to really build upon making bigger systems. And at the end of the day, you know, quantum is a tool that's going to be used by humanity, and and for us at IBM, it just happens that we're really putting our eggs into the superconducting qubits technology. It's the one that works for us across those 3 dimensions, and so far it's been working out. You know, we have, you know, really large number of qubits available to our clients today. And, you know, we'll keep pushing on that as well as the other 2 parts of the equation that makes performance.
Yeah. But how do you then think about this kind of, if it is a sort of hybrid technologies world, as Tobias sort of outlined, that again, you know, obviously you would want to have a large share of that market and so on, but will you, how do you think about kind of fitting into a world in which, you know, different machines may be used for different types of problems, etc., depending on what they're best suited for?
Yeah, so just to make sure that I'm totally clear here and to clarify, we're talking about hybridization in terms of different modalities of qubits versus hybridization of quantum and classical processors.
Yes, I should have been clear. A hybrid is a bad word to use because it can be a bit ambiguous. But no, I did mean a world in which we have multiple types of quantum hardware, or, you know, either being used together or being used by different industries or companies, depending on what problem it is that they're solving.
I think that, yeah, there will be some problems where, for example, neutral atoms just, you know, make a lot of sense to explore. You know, I think when Richard Feynman, for example, thought of the whole concept of quantum computing and simulation, you know, one of his ideas was actually, how do you, you know, prepare your, you know, some quantum system in a state and have it evolved in time, which is which is essentially what the neutral atoms do, right? Now, in terms of the generalizability of quantum, I think that, you know, gate-based type of approaches tend to, you know, they're universal. And that may have lots of applications, outside of just the simulation that, may bring business relevance. But I think it's really up for the use case for the end user to really, think about their benchmarks and, see what criteria is important for them, right? Because maybe you'll have two different technologies arriving at the answer, but one may just do it in a way that, takes in a way that really pays attention to criteria that's important for the end user.
Christoph, you look like you're dying to jump in. So
Yeah. No, but to Stefan, I think he mentioned benchmark. I think that's the very important point. I think you cannot develop these technologies without looking also at what's happening on the classical side. So compared to the best classical hardware. And I think that was a little bit the weakness for me until now. For many startups as well, in software or hardware, they don't necessarily have the expertise in the field they're trying to target for applications like chemistry, like drug design, finance, etc. And things are happening on the classical side, of course, as well. I think there are very good approaches, very efficient. So as a startup, when you provide a solution, you come to a company, you need to position yourself really with respect to what's the best that is actually implemented by the industry. And I think that's been a little bit weak, probably until recently, with companies that have been founded largely by physicists, quantum physicists. But now we see they're hiring more and more computer scientists, people who have deep expertise on the sector they are targeting, and that's very, very welcome. So I think that's super important. You cannot develop quantum really like if nothing else was happening, and benchmarking, like Stefan mentioned, I think is really key. And again, that's a very important point in this paper that was released today. And I expect more efforts on benchmarking. There's a open source approach by Unitary Fund. It's called Metric, which is very important, very interesting. It shows how different approaches compare. And I hope I'm sure we will have more of this in the next months or years. That will be a way also to bring us more customers, more industry to this field, because the community will show they're really comparing to the best what is available now.
Yeah. And Marcus, I think, it's fair to ask whether you have a preference on on type of hardware, or whether that weighs in at all to how you're thinking about this.
Very early on, of course, we also have been invited to, let's say, support particular hardware developments. But as a user or prospective user of quantum computing, we are more, try to keep it an open innovation system. So we have not placed any bets on specific hardware, but we are a supporter of the European and the German quantum computing initiative and so on. So we try to teach the industry what are the needs from the perspective of the chemical industry. But no, we don't place specific bets on hardware at this time.
Yeah. Okay, and then to sort of Christoph's other point, which I thought was interesting, just whether you're seeing startups coming a little bit more prepared now with sort of having something that's specific to the chemical industry need, and is that improving as from what you're seeing?
Sorry.
No, yeah, sorry, Marcus, I think we lost you for a second. I just wondered whether you were seeing sort of, if you're looking at startups now, that are they learning to do this, with a more specifically addressing kind of the way that the needs of the chemical industry? I mean,
yes, I mean, and of course that's again coming back to the investor perspective. That's of course a very fruitful area of collaboration where we, as a partner, we can explain what are our problems today, how do they look like. And then, we throw things on the table and say, well, these are 6 or 8 example problems from our, let's say, R&D department or other areas, where we look for solutions, software solutions, computational solutions, data analytics, and so on. Can you help us with it by using, let's say, by applying quantum computing logic to this problem? And so we are very open in sharing our problems with these innovative players. who say, yes, we are able to provide solutions. And so it's a trial and error situation where I think corporates, of course, provide, in our case, as a corporate VC, we can provide financial resources, investing in these companies, but at the same time, starting these kind of collaborations where we describe in detail what do we need, and then maybe help a startup to get a better sense of what are actually the problems in chemical research or pharmaceutical research or material optimization. How does it work today? And that's something, of course, we are happy to do.
Yep. Tobias, you had your hand up. Were you going to respond on this point about targeting solutions to
maybe some anecdotal evidence to what Marcus said. When we came into the first discussion with pilot customers, we observed precisely that there was some overselling in the recent years. So nobody wanted us to consult them on potential use cases. For example, I think BASF, they detected 150 use cases. They know what they would like to do, and they also know that the hardware and the software in combination is not there yet to provide value. So it's needed to, from our perspective, to talk the truth basically, and not over promising what's possible, to have a clear and solid expectation management, and then discuss steps towards that we get more dots on the line towards something that is then useful for industry users. And that is what we observed, that most of there are around 300, from our perspective, 300 educated companies that have their teams in place, that know what they want, that have hardware and other collaborations in the past. And these are not to, I won't prevent the word, they're not to be they don't want to be overpromised. They want to see stepwise approach towards their usefulness. That's basically the case, and that works even with the largest chemical companies, as I will talk in the future about.
Yeah. So Marcus, you jump in.
I have a question for my friend Christoph, and I mean, we are. Of course, we have seen quantum computing was a topic of the year 2022 until the Sputnik moment in November 2022, when ChatGPT went online and became, let's say, the topic of the year, closer to the finishing line, and it still is. Of course, if you look at what is catching the attention of large corporates, last year, quantum computing would have been and was a great topic. Today, it's a little bit more about generative AI. So I would like to ask Christoph if you see a link between the two topics. Do you think that quantum computing actually can help when we look at large language models, generative AI? Does it fit together, or what's your take?
Yeah. So 2 points. First, about the dynamics, and maybe it's worth saying a few words about that, about what's going on. So we are at the moment fundraising for a new fund, Quantonation 2. So it's a bigger fund, 200 million. The first one was 100. Quite frankly, we see a lot of appetite. I mean, like from both corporates, financiers, etc. Of course, there are challenges in fundraising in some phases for startups at the moment. With respect to last year, you showed some curves, Maya, a little bit earlier. A point of concern for me, which is really important, is how to bring new companies, new projects as well, I mean, to the sector. This curve where you see the rate of creation of companies going down instead of going up. So the next wave, you mentioned that. That's super important. We give a lot of attention to that. And I'm pretty sure on IBM's ecosystem as well, with the relationship with the startups. So, but overall, I would say still lots of appetite from the market, from customers, from corporates. Exploration, a kind of news that IBM is giving today, for me, will be important and will have an impact as well. I'm pretty sure Kipu, Pascal, some other companies, NQ, etc., will do the same. So in terms of dynamics, I think we still see, maybe it's not the first thing people are talking about, still see a lot of appetite, a lot of interest. So that being said, yeah, let's be careful about that. But I think the dynamics is pretty good. Generative AI and quantum, I think that's an AI, well, quantum and AI in general, quantum machine learning, that's a topic people have been talking about for a few years now. I've seen really nice demonstrations from several actors in the field over the last year, like Pascal again at the end of last year. I think had a very nice quantum machine learning experiment. They put it online. I mean, it's working, it's solving a really good need. I think it's not antithetic. Of course, the problem with quantum is the number of variables that you can manage, still restricted. So you have to find, again, what the quantum processor will do in your workflow. I feel it will contribute. It's not that obvious to find exactly how, but it's not necessarily antithetic. I don't have a really good answer to that. People are exploring that. I mean, we must be careful not to add hype over hype here, like quantum generative AI. Is it true? I think I want to see evidence that it's useful for something. But I'm quite confident there will be good angles and good ways, and quantum machine learning is real and will happen and will have an impact. Whether it's generative AI, not so clear for me. Whether it's for large language models, not obvious at first, given the restrictions on quantum machines that you've mentioned earlier, Marcus. Let's say more broadly, quantum machine learning, I think, is a real topic and something that will be important.
Yeah, seems fair. Does that answer your question, Marcus? And I mean, you obviously have a view that I think you feel that, you know, there will be quite a good marriage. And Tobias, is that you?
I don't want to first, Marcus, answer maybe to your question. Yeah. Sorry for stepping in.
No, I mean, also on my side, it's kind of guesswork. But I mean, if we take into account that today the computational power that is used for generative AI is already bigger than what we are that is used for cryptocurrency applications, then of course that points at a new need, and that probably again with classical machines this cannot be matched, this cannot be run. So it's but then of course it must be a good fit, as Christoph said, and if the theoretical basis is working and people are starting to work on a theoretical basis, and then hopefully one day the hardware is there with the thousands of qubits, again, that would be an area where I would be optimistic that quantum computing could help to solve a problem where we very soon or already today have a severe lack of computational power.
And Tobias, did you have thoughts on that?
Yeah, so yesterday we had a discussion with a company an AI company who collected a lot of brain scans and tried to see pattern recognition towards neurodegenerative diseases. I hope I put that right. And of course, with AI and pattern recognition, you can achieve great results that helps you a lot. But at the end, if you want to find out what protein is involved, how does the drug look like that works into the system, how is that drug synthesized, how can I on a classical and quantum approach calculate from the molecule, this is for solvability, this is for passing the blood-brain barrier, and this is actually the active site for the protein that I want to approach. That is not doable with AI from my perspective. And so as I see a combination of classical and quantum computing, these hybrid approaches in that way, also there will be spaces where quantum and AI will overlap, like Christoph pointed out, but there will also be regimes where you don't have existing data. So whatever you ask an AI will not find you a good global optimum because of the data set. So, and that is where, at least if there's not an overlap earlier on in that potential workflow, there is a regime that where quantum is needed. And therefore, I think now the AI hype cycle, and even in my personal life, so to Raoul's questions, I think the best way to get introduced to quantum is write a good prompt to ChatGPT and let you all quantum mechanical language be translated in common language, and that will be maybe the best result compared to a book. Nevertheless, there are areas in understanding nature where quantum computers are needed. And whatever you do with existing data is highly appreciated, and solving problems, but not the problem from my perspective.
Yep. And it would be great to also get Stefan, does IBM have a view in terms of if there's a marriage between quantum and AI that's worth pursuing, and also has generative AI kind of stolen the thunder of the quantum group now a little bit, because
I think that thunder is not a limited quantity. There's way more thunder that can be produced in the future. In terms of the IBM effort as it relates to these large language models and quantum, I think that we're in both of them. So the last big Think conference that we had, hosted by our CEO Arvind Krishna, he that's where we unveiled our Watson X, which is our solution for large language models in the business context. We also spoke about quantum safe as well, and which is something that is near and dear to the hearts of many CISO offices for our B2B efforts. So in the sense of how they interact, I think definitely in a quantum AI definitely is top of mind for all like businesses, tech incumbents, and others. In terms of specifically what we're doing at IBM Quantum, it's too early to tell, but who knows? Maybe we can, maybe that'll be something that we speak of in the future.
Okay, so we're pretty much at the end of the session now. I'm sorry we haven't really gone into a deep dive, but I hope we did sort of at least address some of these questions. So yes, I think that was a good suggestion that use generative AI, use ChatGPT to get you started on your understanding of quantum computing. And hopefully we touched on some of those issues about gate fidelities, a little bit on optimization versus general purpose quantum. So I think it's probably time to kind of bring this to a close. I have a couple of housekeeping notes at the end just about some future events, but at this point I would really like to say a great big thank you to the panel who sacrificed some of their time this afternoon to talk us through a complex subject. So thank you so much, Marcus, Tobias, Stefan, and Christoph. Really value the insights. I hope that's been useful for us. If anybody would like to, has further questions and so on, do contact me. I'm going to put my contact details up in just a moment, and so I can help facilitate any further connections if possible. We will be writing about quantum more, so and we'll be definitely watching to see if that investment curve starts to move. So kind of do keep following us on GCV to see that. So so thank you very much, panel. I'm going to just give a couple of closing housekeeping things now. So if you enjoyed this webinar, our next one is on July the 12th. This is about, we've called it treasure hunting from seed pearls at universities and national labs. And this is really about how large corporations can engage with universities and national labs to kind of go in for those really early stage companies, maybe find things before they become too well known, looking at some best practice models for people who are doing that well. And so hopefully that will be a nice practical session for those of you who are interested. These are my contact details. If something in this webinar piqued your interest, drop me a line and I will kind of help facilitate any further fact finding on that. There will be a replay, and then just some forthcoming events. So again, this is more generally for GCV. These are some of our live in-person events. Next week is our big London symposium. So I'm hoping to see a lot of people there. And then we do regional events in the US and Brazil, and we're going to be in Japan and South Korea in November. So if you are in one of those geographies and want to catch up, do again, see the GCV website for more details about how to get involved. And the other thing that I would say is we run a fantastic thing called the GCV Institute. So this is really for people who are corporate venturing professionals. If you have a young team that needs to learn some of the fine art of how to do this well, we run programs throughout the year. We also have programs for helping your C-suite understand the value of corporate venturing, and I would also recommend those. And for people who listen to our webinars, there is a 20% discount code off these. So I feel like a real salesman now pushing that, but do make a note, and that is it. So thank you everyone who joined us. Thank you again to the panel. That was really enlightening. I feel like I have caught up a little bit on what the latest is. And I really can't wait to see. I think this next couple of years is going to be so exciting in this space. And I guess we'll answer some of those questions that were left a little bit unanswered, maybe when those first real use cases start to roll out, or whether we can meet those further milestones in the hardware availability, which seems to be the big bottleneck. I think that maybe we can do this one again and see where we are, in a year's or two's time. So without further ado, thanks again.